Hey, scientists, Mr. Kennedy here. Okay, so we're just going to do a quick recap of what you have learned from the Earth puzzle. Today, we are looking at the life cycle of a star, how a star is formed, and how that star lives through its life until it dies. As you learn from the Earth puzzle, the birthplace of every star is the nebula. Okay, real key important concept to understand that where stars are formed, where they are birthed from, is the nebula, and the nebula is just dust being collected together by gravity. And as that collection takes place, nuclear fusion begins to occur at the core. And once nuclear fusion starts occurring, energy and heat is given out. Okay, so that energy is given out in form of heat and light, and that makes that object to become a star. Now, based on the mass of that star, it could either be an average star or a high massive star. Okay, so that is the main difference to note there as well. So this would be a high mass star, and then this would be an average star, just like our sun as well. At this point, all of these are in the main sequence of a star. Okay, so this is like the early, or say the baby phase of a star. So we can just say the young phase of a star. And in your Earth Science reference table, page 15, that would be the main sequence or the early stage. So those are the stars that you will find along that path. So all those stars are babies, they are newborn, just like our sun. And from that phase, stars will move into their giant phase. That giant phase could be either a red giant phase or a red super giant phase. Okay, there's a difference between giant and super giant. All right, so average stars like our sun will just proceed to the red giant phase, while high mass stars will move into the red supergiant phase. And at that point, they are no longer in the main sequence, but now they are in the intermediate, or say maybe adulthood. Okay, or intermediate phase. And that phase in your Earth Science reference table is the giant phase. Excuse me, is the giant phase. Ew. All right, so that would be the giant phase or the super giant phase of that star. And both the red giant phase and super giant phase are the intermediate phase of a star. Now, going back to the life cycle of a star. Now, a supergiant star would explode into a supernova. All right, so really important for you to know that a red giant phase would not explode or would not make a supernova. All right, and then from a supernova would have a neutron star or a black hole. Okay, while an average star would not form a supernova, it would just form a planetary nebula, and from there they'll move to the dwarf phase. And in your Earth Science reference table, that will be the phase that you will see at the bottom right here, which is white dwarf. That is the late phase of the star, or the old age of the star. So we can at this point say all of these is old age of a star. Okay, so let's use all this information to answer some questions, some recent questions. Let's go back to my browser and we can answer this question. Okay, so question number 1. The accompanying graph represents the brightness and temperature of stars visible from Earth. And the question is, what location on the graph best represents a star with average brightness and temperature? Average. What do I know about average? Okay, that's a key word for me there. So average is something that is in between, not on the extreme. It's just in between. So I'm looking for something that is in between, a brightness that is in between and a temperature that is in between. So let's first look at the brightness. Brightness is luminosity, as we've learned from our vocab and from our previous lesson. So average luminosity will be something that will be in the middle. So I'm going to extend that, and I can see that this area marked B would be a good representation for average luminosity. But the question is average brightness and temperature. So average temperature also would also be in the middle. So this is hot and this is cool. So in the middle, I'm going to extend that. So this area marked A is actually average temperature as well. So my answer could be either A or B. My question says represent a star with average brightness and temperature. So A only represents average temperature. A does not represent average luminosity. B, on the other hand, represent average luminosity and at the same time average temperature. So my correct answer should be B. And that means my answer to this question will be right here, B, which is the area representing that average temperature and brightness. So my answer is B. So moving on to question number 2, base your answer to the following question on the diagram below, which shows two possible sequences in the life cycle of stars, beginning with their formation from nebula gas clouds in space. And we have that lovely diagram there. And the question says, according to the diagram, the life cycle path followed by a star is determined by the star's. The life cycle followed by a star, like we learned from here, we learned that the path that a star would follow will be based on its size, its mass. Okay, if it's a average mass, it's going to follow that path. If it's a high mass, it's going to follow this other path. So I sure know for sure size and mass plays a big role. So A says mass and size. There it goes. I know the answer is A already. B, temperature and origin. No, temperature does not determine what paths a star is going to follow. And besides origin, all stars originate from the same place, right? All stars originate from nebulas. C says luminosity and color. No, luminosity depends on size, color depends on temperature. That does not determine the path a star would take. D says luminosity and structure. No as well. So my answer is A. So I pick A. Let's move on to question number 3. Stars like Earth, Sun most likely form directly from A, nebula, B, supernova, C, red giant, D, black dwarf. Well, we said the birthplace of a star, where they originate from, where they are formed, is a nebula. So easy breezy. My option will be A. It cannot be B. Supernova is actually the death of a star. It's the death of a massive star. So supernova is not it. Red giant is the intermediate phase of an average star. Black dwarf is the final phase. It's just like black hole of a star. So this supernova talks about is the ending part. Black dwarf is the ending part. Red giant is the intermediate part, while nebula is actually the beginning, the birthplace where all stars are formed. So my answer here will be A. So our last question before I let you guys go to work on your test wizard question. Question number 4. Which two stars have the most similar luminosity and temperature? Betelgeuse and Bennu star. B, Rigel and Betelgeuse. C, Alpha Centauri and the Sun. D, Sirius and Procyon B. Okay, so I'm going to use my Earth Science reference table to answer this question. What two stars have the same or have similar, let me look at that question again, have similar luminosity and temperature? So I'm looking at luminosity right here and temperature. What two stars share the same. I see Sirius here, and I can't see any other star that shares the same temperature or the same luminosity with it. I see our sun here, and Alpha Centauri, and they share the same temperature, and their luminosity is almost the same, same luminosity of almost 1. So is that part of my question? Yeah. See, Alpha Centauri and the sun, and there goes my answer. Definitely it's not Betelgeuse and Bennu star, because those two stars are really far apart. Okay, Bennu star is right here, and Betelgeuse is all the way up. One is very small, one is very big. They are far apart. The other option is Rigel and Betelgeuse, and I see Betelgeuse here, and I see Rigel here. Both of them definitely do not share the same temperature when you extend that down to the temperature line. But of course, maybe they share the same luminosity if you extend that to the left. But temperature, no. So that is out as well. Sirius and Procyon B. Let's see where those two guys are. Sirius is right here. Procyon B is here. If I extend this, is maybe the temperature will be similar if we extend it to the temperature line. But when you extend it to the luminosity, they are far apart. So our answer here definitely has to be C. And ladies and gentlemen, that is it. So I'm going to let you guys fly and move on to your test wizard, where you're going to answer some more practice questions. See y'all. Bye.